Today we're looking at how we find the equation of a straight line passing through 2 points. If you look up here at the aim, you can see a good model for how we break down these questions. So looking in green, we want to see what's the command word, and it's to find. It tells us what we need to do, talks about a thing, which is the equation. So we're looking to find the equation of a straight line. Now the fact that it's a straight line gives us a lot of information as to how we might find this, and the fact that it passes through 2 points, well, this is the information that we'll need to actually work everything out. You're going to see as we go through this that most of these questions follow this format, and it's pretty easy once we recognise it. So let's start with what we know. We know that a straight line looks like y equals mx plus c. We've got our gradient here, the m, and our y-intercept, the c. So generally speaking, if we're looking at a question, we're going to need to be able to identify these things and be able to use them to our advantage. So let's take example 1. It says find the y-intercept and the slope of each of the straight line graphs defined by the following equations. Well, again, we need to find something. We need to find the y-intercept and the slope, or the gradient. So the two things here are y-intercept and slope. Now, we're talking about what are the y-intercept and slope of what? Well, it's of the straight line graphs, and it's handy that we know they're straight, and we know that we're referring to the following equations. So there's a straight line, which means it's going to follow y equals mx plus c, and it's the equations down here. So let's look at y equals 5 plus 3x. If we said y equals 3x plus 5, that's the same thing. And in this form, we might notice that m equals 3, which is that number next to x, our gradient, and the y-intercept, so that would be, my plus c, is 5. Now the way we refer to the y-intercept is when x is 0, y is 5. Let's extend this to part b. Once again, it might help us to rewrite this as negative 5x plus 10. It's the same thing as 10 minus 5x. And we can see our gradient, m equals negative 5, and our y-intercept is 10, so we'll say the y-int is equal to 0, 10. Now part C requires a little bit more work. We need to get it into the form of y equals. So the first thing we'll do is add this quantity, this plus 3x, to both sides, and we get 2y equals 3x plus 6. If we divide by 2, y equals 3x on 2, so we'll divide the first term, and we'll divide the second term. 6 divided by 2 is 3. From this form, we can see that our gradient, m, is 3 over 2, because that's the coefficient of x, and our y-intercept is equal to 0, 3. Now here we get the diagonal line y equals 7x. It's easy to see that our gradient is 7, but we can't see a y-intercept. All this means is that the graph passes through the origin. This is the same as 7x plus 0. So my y-intercept is simply 0, 0. So we can see that we now know what the gradient is and what the y-intercept is, and if we have that information, we could put into the form of y equals mx plus c. But we might have to think of, well, what is this idea of enough information? So if we say that we had enough information, we'd be able to find the equation of a line. Well, enough information is 2 points, because 2 points allows us to find the gradient using m equals y2 minus y1 over x2 minus x1. And we could sub in the extra point to figure out the rest of the graph. So the way that we do this is we make use of this formula. Y minus y1, being the y coordinate of a point we have, equals m outside of x minus x1, the x coordinate of that point. So it seems a little bit complicated, but as we do an example, you'll see it's really quite straightforward. The question here says find the equation of a line which passes through the point 1, 4 and has a gradient of -2. This is really straightforward because we've got our two key pieces of information. It passes through that point and has a gradient -2. So for our procedure, we can start quite simply and say let's label what we have. Well, x1 and y1 are equal to 1 and 4 respectively. My gradient is -2. The next step would be to write the formula. The formula in this case is y minus y1 equals m outside of x minus x1. You may have guessed at this point that all we need to do is substitute in the values we have. So step 3 is to substitute. My y1 in this case is going to be 4 and my x1 is going to be 1. My gradient is -2. So when we put that into our equation, it looks like this. Y minus 4 outside of -2, x minus 1. Now remember that when we're looking for the equation of a straight line, we like to give it in the form y equals mx plus c. So our last step is just to solve for y on its own. First thing I could do, y minus 4 is the expansion of these brackets. That is -2x plus 2. So -2 times -1. To get y on its own, I just need to add 4 to both sides. So y equals -2x plus 6. Here we can see that what we have is the equation of a straight line, exactly what we were asked to find. Do we know that it has a gradient of -2? It sure does. Do we know it passes through the point 1, 4? Well, if I sub in 1, I should get the answer 4. -2 times 1 plus 6 is -2 plus 6, which is 4. So we can certainly conclude that this is a straight line and it passes through 1, 4. Occasionally we'll see that it's not as straightforward as here is the gradient, here is the point. For instance, we're being asked to find the equation of a straight line passing through the points 1, -2 and 3, 2. Remember, we always want to look for this phrase passing through. That's always going to tell us the information that we need. So the line was passing through these 2 points. Doesn't mention anything about gradient, but I do know that I could always find the gradient by saying m equals y2 minus y1 over x2 minus x1. That is, the gradient is, this is my y2, 2 minus my y1, -2, over my 3, which is x2, minus my x1, 1. So 2 negatives make a positive, and we end up with 4 over 2, that is a gradient of 2. So the first thing that I know is that I have a gradient of 2. Let's label that. I then know that I have a point. I don't like negative numbers, so I think the easier one to use here would be 3, 2. So I'll say that my x1, y1 is equal to 3, 2. It doesn't really matter which point we use, as long as we choose one. So, now that we've got the information we need, we can follow the process that we had before. That is, we can label what we have, substitute the formula in, substitute the values into that formula, solve for y, and check our answers are correct. So we've done the labels, let's write out the formula. Y minus y1 equals m outside of x minus x1. If I'm now substituting in values, we can see from above, my y2 is 2, my x1 is 3, and my gradient is 2. We can solve for y by saying 2x minus 6 on the right hand side is equal to y minus 2. And if I add 2 to both sides, this time we can see y equals 2x minus 4. Let's just double check that we've answered the question. We've certainly found an equation, and that is an equation of a straight line because it's in mx plus c. does it pass through both points? Well, the point 1, negative 2 means when I sub in 1, I should get negative 2. So 2x minus 4 becomes 2 times 1 minus 4, which is 2 minus 4, or negative 2. So that point worked. Let's double check my other point. When I sub in 3, my answer should be 2. So when I sub in 3, I get 6 minus 4, which is indeed 2. What I found is the equation of a straight line which passes through both those points. Further to this, we're not always given information in words. So we've just seen that we can find the equation of a straight line if we're given 2 points, but occasionally that won't be in words. In this instance, we can infer the points from the graph. So we can see this dot here, the number 4, well that's actually a y-intercept. I know that when x equals 0, y equals 4. So this will serve as my x1, y1. I can see the x-intercept here of 2 means when x is 2, y is 0. That'll serve as my x2, y2. So I know I've got a point. I also need a gradient. In order to find the gradient, we know m equals y2 minus y1 over x2 minus x1. That is 0 minus 4 over 2 minus 0. So we get negative 4 on 2, which is negative 2. That makes sense because when I look at the graph, I can see it's going down. So I've got m equals negative 2. I might use this point 2, 0 as my other point. Now I'm ready to follow all the steps we did before. The formula, y minus y1 equals m outside of x minus x1, becomes y minus 0, because that's my point here. I know that that equals negative 2, because that's my gradient. So that equals negative 2 outside of x minus x1, and the x1 that I chose was 2, which is here. So that doesn't matter, and we end up with y equals minus 2x plus 4. Let's check our answer. We certainly found the equation of a straight line. The gradient is negative 2, which makes sense when I look at a graph here that's going down with time. And I can see that the y-intercept is 4, which is the c that I got. So absolutely, this is a valid answer. So there are some things that we need to remember. We need to remember that if it's a horizontal line, as we can see here, well, that equation is just y equals 2, because it passes through the point 2. No matter what the value of x is, the graph is always 2. With a vertical line, this takes the form of x equals something. If I can see it passes through the point 3, I know the graph was x equals 3, because no matter what the value of y, it's always true that x equals 3. Generally, we can look at the point gradient form, or what we might call our formula for finding the gradient, is simply requiring 2 points. We know this as y2 minus y1 over x2 minus x1. So I wouldn't worry too much about this little bit. We also know that we can always use this formula, y minus y1 equals m outside of x minus x1, if we have a gradient and a point. We need to remember what horizontal and vertical lines mean, as they're a different way to find that. That usually requires us to look at a graph and just infer the answer.